Show that A and A prime A have the same null space and therefore also the same rank. To show that the matrices have the same null space, we need to show that they map the same vectors to 0. In other words, we need to show that if AV equals 0, then A prime A equals 0, and if A prime AV is 0, then AV is equal to 0. The first one follows directly by multiplying on the left by A transpose. For the second one, we multiply on the left by V transpose. We can then write the left-hand side as the squared magnitude of AV. The only vector whose squared magnitude is 0 is the 0 vector, so we can conclude that AV is equal to the 0 vector. Therefore, A and A prime A have the same null space. By the rank nullity theorem, this implies that they have the same rank as well. We define a function mydiv which divides each entry of a matrix A by a real number x by first defining a matrix B which is filled with zeros and has the same shape as A, and then looping over the entries in order to set each entry of B to be the corresponding entry of A divided by x. We then check that our function does what we intended it to do. To find eigenvectors of the matrix 4, 1, 1, 4, we look for vectors whose direction is preserved as we adjust the slider. It takes a bit of searching, but we can see that the point 1, 1 stays at a 45-degree angle. We can also see that the point -1, 1 stays in the same direction. The matrix -2, 1, -1, 2 is trickier, but the point 4, 1 looks like its direction is approximately preserved as we adjust the slider. The same can be said of the point 1, 4. The matrix 2, 1, -2, 2 is trickier because it really looks like every vector is getting turned. Here we might say there are no eigenvectors. In each case, we can check using Julia what the eigenvalues and eigenvectors of the matrices are and confirm our findings.